Hello guys, today we are looking at the second example under the four-term series of examples on projectile. Now, this very series is the last series of examples, on projectile. After this very set of questions, you should be pros when it comes to solving anything that has to do with projectile. So right here today, we have an object is projected from a height 80 meter above the ground with a velocity of 40 meter per second at an angle of 30 degrees with the horizontal. What is the landing velocity of the object? Now, the first thing we have to do, don't forget, we try to interpret this using a diagram. Let's see how we can interpret that. An object is projected from a height 80 meter above the ground with a velocity of 40 meter per second. At an angle of this is the initial speed. Initial velocity is 40 meter per second. The angle of projection is 30 degrees with the horizontal. Now, this was done from the top of an elevated surface. Now, it could be on the top of a building, it could be any elevated surface. So let's say it's a building actually. Let's assume that it's projected from the top of a building. Somebody stands here and projects an object from the top of a building like this. It throws it up against the horizontal like this. And this was done at an angle of 30 degrees. So what do we have? We have a projection that goes this way. The object gets to max height, then falls down like this. So what are we asked to get? We are asked to get the landing velocity of the object. Now don't forget that for us to get landing velocity, we will need two major components of velocities. We need the final velocity along the x-axis and the final velocity along the y-axis. Don't forget that the final velocity along the x-axis is the same thing as the final velocity, as the initial velocity along the x-axis, because there is no acceleration on the ground. That's the reason. We've seen a couple of that in our previous lessons on projectile. So what we're going to do first is this. Don't forget what we have here is trajectory. We are looking at the path of flight. We are not talking about max height, so we are not really talking about range and the other ones that we derived different formulas for. So the first thing we're going to do, first of all, we know that this very object was projected from a height of 80 meter, the height of this building. It could be a building, it could be anything. I only assume that there's a building. This 80 meter, that's the height. Now this stuff was projected. Now for the fact that it was projected, it's going to get to another height. It will attain the max height. Now the max height will be added to this height that we have already. We already have a height, I beg your pardon. We have a height of 80 meter. So this stuff was shot into the air, went into flight. Now it's going to get to max height. Now from max height, they start dropping back to this place. So let's see. Let's get the max height first. That's the first thing. Let's get the max height. It will contribute to the distance along the y-axis. So what's the formula for max height? The formula for max height, quickly let's get that. For max height, h max, don't forget, that formula was derived from v squared equal to u squared plus 2as. At max height, final velocity is 0. So the u sine this along the y-axis, don't forget. So this u sine theta raised to power 2. So I can send this to the other side, and this minus 2gh. So at max height, minus 2gh. So at h max. So at max height, the formula is u squared sine squared theta over 2 gravity. That's what we have at max height. That's the formula at max height. So when we get the distance at max height, that's the max height attained, the next thing is, once we get the max height attained, it's very easy. That means we've gotten the total distance along the y-axis. So we can use that to get our final velocity along the y-axis. So let's get the max height. So the h max, the max height attained, initial speed is 40 meter per second, 40 raised to power 2 times sine. The sine 30 raised to power 2 divided by 20, that's 1,600. Sine 30 is 1 over 2 raised to power 2 over 20. 2 year 1, 0 comes 0, 2 year 1, 2 year 80. So what do we have? This 80 times 1 over 2 raised to power 2 is 1 over 4. 4 year 1, 4 year 20. So the max height attained is 20 meter. So this stuff got to 20 meter. That's the max height. So from 20 meter, it's going to fall back. Like from this 20 meter, this at max height, that means the total distance from this place down to where it dropped, that's down to the earth, is 100 meter. So we have 100 meter from here to here. So don't forget, we can easily get our, let's get our component of velocity, of initial velocities. Don't forget that initial velocity along x-axis is u cos theta. So what is that? That is, what do we have? Was a speed that's 40 times cos 30 degrees. We end up having 34.64 meter. While the initial speed at that's along y-axis is 40 times sine 30. 40 times sine 30 is 20 meter per second. 20 meter per second. So don't forget the initial speed is the same thing as the final speed along the x-axis because there's no acceleration along the x-axis. So the final speed along the x-axis is the same thing as the initial speed, 34.64 meter per second. That's what we have right here. It's as simple as that. So what we're about to get right now is the final speed along the y-axis. So we know the initial speed already is 20 meters per second. So we need the final velocity along the y-axis. Now, how do we get the final velocity along the y-axis? Don't forget, when this object gets to this very height, you know, at max height, the final velocity is 0 meter per second. That's at max height. We all know that. At max height, the final velocity is 0 meter per second. So for the fact that when it gets to max height, gravity sets in and sends it down to the ground, sends it down to the earth. So it means what used to be the final velocity will become the initial velocity for us to have a new final velocity. So normally at max height, final velocity is 0 meter per second, but this is going to become initial velocity because we're going to have a new landing velocity along the y-axis. So now we're going to have a new one. The final velocity along the y-axis, we don't know what it is. We know the total distance along the y-axis to be 20 meter plus 80 meter, 100 meter. That is known, as simple as that. So we have this. Now acceleration along the y-axis now will be plus gravity because the body starts falling. We are considering the fact that the body drops from this place down to the earth. That's what we are considering. So quickly, we're going to use our v squared equal to u squared plus 2. This is equal to u squared plus 2s. Everything along the y axis. So the final velocity is what you're looking for, v squared. Initial speed, the initial speed we have now, which is to be the final speed, 0 squared plus 2 times 10 gravity times distance. The distance is, what do we have? 100. So the final velocity squared, that's 0. So 2 times this is 20. 20 times this is 2,000. So the square root of the result, 2,000. Let's get what we have there. So that's 10 root 2, square root of 2,000. It's 10 root 2. So let's see what we have. Let's see what we have there. Square root of 2,000. That's 20 root 5, I mean. So that's 44.7. 44.7 meter per second. There's the final velocity along the y-axis. So the body was shot to this place. It got to max height. At max height, it lost all the speed it left with, all the speed along the y-axis. It left with an initial speed along the y-axis of 20 meters per second, and also an initial speed along the x-axis of 34.64 meters per second. Now, after he did that, he got to a max height, thereby losing all its initial speed along the y-axis from 20 meters per second initial speed to 0 meter per second. So at this very point, gravity sets in and starts, it sets in and starts and pushing it down. So from this very point down to this place, the landing velocity, the impact, what used to be the final velocity 0 meter per second becomes the initial speed 0 meter per second. Now we have a new final velocity through a distance of 100 meter, acceleration being positive gravity. So what do we do next? The next thing we're going to do, since we have the final velocity to be 44.7 meter per second, initial velocity is 34.64 meter per second. So we're going to bring them together to get our landing velocity. That's the next thing we're going to do. So we take up this very space. We'll take this off to get so don't forget the object drops at this very point. There's a landing velocity with its component, along the y-axis, and along the x-axis. So this is what we have. So there's a landing velocity, final velocity. So this is it here along x-axis and us along y-axis. An angle with D. There's a landing angle with the horizontal. So don't forget, what do we have already? We have Along the x-axis, you have 34.64 meter, 34.64 meter per second. Along the y-axis, we have 44.7 meter per second. So we have more impact along the y-axis. So what's going to be the landing velocity? You're going to use our Pythagoras theorem to get that. I said 34.64 meter per second. So you know what it is? V squared equals to 44.7 squared plus 34.64 squared. So V squared, let's use our calculator to do that. So 44.7 squared will give us 1998.09 plus we have 34.64 squared, 1199.93, 1199.93. So we're going to sum them up. The two results of V squared is this result 1199.93 plus 1998.09. What do we have? We have 3198.02, 3198.02. So the square root of the result will give us our landing velocity. So square root of the result, 56.55, 56.55 meter per second. So this is a speed the very object lands with. It lands with this impact. It makes an impact of 56.55 meter per second. So this very question that we just got the landing velocity of this object shows a true life scenario. Now, I don't know if you've heard of certain countries having issues with other countries. Now, in order for this very country assaulting the other country, in order for them to break through the defense mechanism of the country they're assaulting or fighting against, most times they will have to shoot their missile into the space in order for it to gain momentum and hit the target with a greater impact. So as you can imagine, the stuff was shot with a velocity of 40 meters per second right into the air, and it lands with 56.55 meters per second. So it lands with more speed. Instead of shooting it directly, it's been shot first into the air. Imagine the stuff being shot into space for you to hit its impact. So that's the reason why some missiles are launched into space, launched into a different higher body before it hits its target, all thanks to projectile. So if you found this lesson resourceful, please subscribe to this very channel and share the lesson with others. See you in the next lesson. Thanks.